Hello everyone, I'm gonna try to explain you how to solve the exercise number 4 from the midterm that you did. So the question is, how much of each component do you need to make 375 ml of 100 millimolar trees, 0.1% NaCl, and 129 millimolar of sucrose? Knowing these molecular weights: trees powder molecular weight 121.14 grams per mole, NaCl powder molecular weight 58.4 grams per mole, and a sucrose solution at 10 molar concentration. So the first thing that you have to notice here is that you have to calculate everything for the final concentration of final volume of 375 ml. The other thing is that even though you are given these molecular weights here, you might not need them all, so be careful with that too. The third important thing with this type of questions is then that you have to notice that the alternatives are given to you in different units. So for the case of the trees, it can be either grams or milligram, the one that is correct. Same applies for the NaCl, and the same for sucrose, that is in liters or ml. So you have to be really careful with that and make sure that you are choosing the right type of units for each of them. So let's start with the trees. So the trees molecular weight, because you're asked in millimolar, so you will need the molecular weight. The molecular weight is 121.14 grams per mole. Now, with that information, you will know that in 1 liter, if you have 121.14 grams, that will be equal to a 1 molar solution. And you also know that 1 molar is the same than 1,000 millimolar. And I'm doing that conversion right now because I'm asked in a final solution at a concentration that is given in millimolar. So it will make life so much easier if we start working with millimolar right away. So you know now that 121.14 grams in a liter is equivalent to 1,000 millimolar. So what if we want to make a solution that is 100 millimolar instead of 1,000? So 121.14 grams is 1,000. 1,000 millimolar. And then how many grams do you need for 100 millimolar? And then we will cross multiply opposites and divide by the leftover one. So that means that it's going to be 121.14 grams times 100 millimolar divided by 1,000 millimolar. We can cancel units, and now we make sure that actually is correct, because one of the reasons is that we have the only unit left is the one that we are looking for, that is the grams. We can simplify here as well. So at the end we have to do this calculation. 121.14 divided by 10, that's equal 12.11 grams. But you have to remember that all of this calculation is for a liter. So now you know that you need 12.11 grams in 1,000 ml, that is the same than a liter, to make a 100 millimolar solution. But you want to know how many grams do you need for 375 ml, that are the ones that you're asked for. So then again we cross multiply. Is 12.11 grams times 375 ml divided by 1,000 ml. We cancel units, so we know that is correct, it's in grams. And now we do the calculation. So 12.11 times 375 divided by 1,000 is this equal to 4.5 for 125 grams. But we have to remember that also so that's the correct answer. And then so then you have to notice that you can answer also in milligrams, so we have to multiply by 1,000 to get it in milligrams. So it's 454 1 milligrams here, and that's also correct. And then we're gonna solve for the NaCl. So the NaCl, you will not need to use the molecular weight because it's in percentage. You are asked for making a solution that is 0.1%. So if you have to remember here that it's always in 100 mLs. So for example, if you want to do a 1% solution, it means that it's going to be 1 gram in 100 mLs. So it's the same number that is you're given in the percentage here, but in grams, but always in a total of 100 mLs. So you know that 0.1 grams in 100 mLs are necessary for making a solution of wherever. It can be candies, it can be pencils, it can be salt, it can be juice, wherever. But then you need 0.1 grams per every 100 mLs, but you know that you need to make 375 mLs. So then we are looking for that number. Then again, cross multiply 375 mLs times 100 mLs and divided by 0.1 grams. Sorry, I made a mistake here. 300 sorry. Oh, so big. So it's 0.1 grams times 375 mLs divided by 100 mLs. Now we cancel the units ml. We're left with the grams, are the one that we need, and so now is 0.1 times 375 divided by 100. That is equal to 0.375 grams. But you have to remember again that even though that's correct, you are given also the answers in milligrams. So then you just multiply that by 1,000, and you have to know that conversion. So it's 375 milligrams. So these two are correct for the NaCl. Now with the sucrose, you are told that you start with the stock at 10 molar, and you are told to make a final concentration of sucrose in millimolar. So I'm going to go ahead, and the first thing that I'm going to do is convert those 10 molar into millimolar. So 10 molar is equal to 10,000 millimolar. And I'm going to start with that, and now it's super easy with a C1 B1 equals C2 times B2, in which you had your stock that is 10,000 millimolar, and you don't know how much do you need, but you know the final concentration that is in 129 millimolar, and you know the final volume that is 375 mLs. So this is X is going to be 129 millimolar times 375 mLs divided by 10,000 millimolar. Cancel those units. We know this is correct. We're getting in mLs finally. So then this is 129 times 375 divided by 10,000 is equal to 4.8375 mLs. But you're also given the option of given the answer in liters. So then we divide this by 1,000 and it's 0.00483 liters. This is the correct answer. So one strategy I have seen students doing is try to erase all the answers that are not correct. So even though we have a decimal that is not exactly matching, we know that the correct it should be the 4.542, so this one here. But also because we calculated in milligrams, we know that the A can be also correct. But this one is not correct, this one is not correct, and this one is saying that B and D could be correct, and we know already that D cannot be correct, so we discard that. So we only have to choose between an A and B. So then now we go to NaCl, so we know that it can be 0.375 grams. We have it here, is correct, or it can be 375 milligrams. So we cannot choose yet because all of them are correct actually for the NaCl. In the case of the sucrose, we know that it can be 4.8 mLs. So the ml, this is not correct for sure. This is not correct. We know it from before, but there in mLs this is not correct. So now we just have to confirm that this one is correct. And if we look at our calculation in liters, we see that this is correct. So that makes alternative A the right one. Thank you for watching.